we will differentiate logarithmic and exponential function, and we will need a differentiation formulas. You may pause the video here and just go through all of these formulas and make sure that you know all of them. Let's differentiate. Differentiate y equals to e to the power of sine x. Derivative of e to the power of sine of x is e to the power of sine x, and times derivative of sine of x, which is the inner function, which is cosine of x. Done. Differentiate y equals to square root of x times e to the power of 5x. Okay, we do have more complex function because we have outer function square root and the inner quantity x times e to the 5x. Let's just recall derivative of square root of x, just simply square root of x, is just 1 over 2 root x. Using the power rule, we can get this. I mean, that's what we will use. And of course, the chain rule. Derivative of the square root, it's 1 over 2 identical roots, which I will put inside x e to the 5x, and times derivative of the inner function, which is x times 5 to the x. Okay, let's copy this. Okay, and now derivative of the inner function, we see that we have product. Okay? If we have product of two functions, f times g, derivative of the product is f prime g plus f g prime. Okay, we do remember this from calculus 1. So now we will use that. Derivative of x is 1 times e to the power of 5x plus x times derivative of e to the 5x is e to the 5x times derivative of the exponent 5. Ooh, wow. Okay, let's simplify. I can put the entire expression on the top of this fraction, and I can factor out e to the power of 5x. And I will have 1 plus 5x. Okay, not bad. Actually, I can leave it like that. I can still combine e to the 5x, but let's just leave it this way. Because the point of this session is to practice derivatives of log and exponential. Okay, differentiate 2 to the power of x squared minus 1. This is general exponential function. That means derivative is the same function, 2 to the power of x squared minus 1, and times natural log of the base of 2, and times derivative of the exponent. I can copy this. That's part of the formula, and derivative of x squared minus 1 is 2x. And maybe we can rewrite a little bit. I can put maybe 2x ln of 2. Actually, I didn't simplify. Okay, let's leave it like that. Okay, differentiate 8 to the power of root x. It's a general exponential function. Then derivative is the same function times ln of 8, ln of the base, and times derivative of the exponent, derivative of the square root of x. 8 root x, ln of 8, part of the formula, and we just learned the derivative of the square root of x, it's 1 over 2 root x. And let's just leave it. Differentiate y equals to x times 7 to the power of sine of 2x. Product rule, and inside the product rule, exponential function and chain rule. Derivative of x is 1 times the second function plus x times derivative of 7 to the power of sine of 2x is the same function, 7 to the power of sine of 2x times derivative of sine of 2x. Okay, let me rewrite. This will be, actually I can factor out 7 to the power of sine of 2x. I can factor out, and I have 1 plus x, and derivative of sine of 2x is cosine of 2x and times 2. Of course, follow the chain rule. It means the final form is 7 to the power of sine of 2x, 1 plus 2x cosine of 2x. That's the only thing that I can simplify, rewrite, because we know that that's the angle and we can't really touch or expand the angle. Angle will stay like it is. Sine of 2x, cosine of 2x, we can see this. Okay, differentiate. Y equals to pi to the power of x times sine of pi x. That's times. Again, product rule. Derivative of pi to the power of x is pi to the power of x times ln of pi. Okay, that's the general exponential function. And times the second function, sine of pi x, plus first function, pi to the x, times derivative of sine of pi x. Derivative of sine of pi x is cosine of pi x times pi, which is derivative of the inner function. And what I can do, I see the common factor pi x. Let me factor out, and then natural log of pi times sine of pi x will stay, and pi times cosine of pi x. And we remember, we can't really touch the angle. The angle was pi over x and stays like this. Yeah, just a little bit of trigonometric properties. Okay, actually, this is the final answer. Okay. Exercise number 7. Differentiate natural log of sine of e to the x. Okay, we do not have product here. We just have two inner functions. Sine is the inner function and e to the x is the inner function. Okay, let's recall derivative of natural log of x is just 1 over x. Okay, this is one of the formula that we have to know. Okay, that means derivative of natural log of that item, it will be 1 over that item, sine of e to the x, times derivative of that item, sine of e to the x, is sine of e to the x. Okay, I can copy this, sine of e to the x, and derivative of sine is cosine of the same angle, cosine of e to the x, times derivative of inner function, which is derivative of e to the x is just e to the x. Okay, let's simplify. I can put cosine of e to the x and sine of e to the x on the top, and I can keep this for now here. And actually, I can't simplify, but I can rewrite cosine and sine of the same angle as a function cotangent. Cotangent of the same angle, cotangent of e to the x. And that e to the x I can place in front. Okay, this is the nice final answer. And again, please note the original angle e to the x didn't change. Yeah, because sometimes we're trying to differentiate inside, but no, we will always put as a property of the, like a chain rule, we will put the derivative outside. Okay, and I think I have a few more. Differentiate log base 5 of x e to the x. It means inside we have product. Let's see, derivative, let's recall, derivative of the general logarithmic function, log base a of x is just 1 over x, the same like for the natural one. However, we have to multiply by natural log of the base in the denominator. Okay, that's we will have derivative of log base 5 of x ex. It will be 1 over x e to the x and times ln of 5. Okay? And times derivative of that guy, because that's the chain rule. Derivative of this. Okay. I can keep x e to the x and natural log of 5 in the denominator, and on the top I will place this derivative, but we have to remember product rule. Okay, derivative of x is 1 times e to the x plus x, and derivative of e to the x is just e to the x. Really nice. Let's factor out e to the x. 1 plus x will stay, and then x times e to the x times ln of 5. And we can nicely see a common factor, e to the x. And the final answer is 1 plus x over x ln of 5. That's the final answer, really nice. And okay, another one. Differentiate y equals to natural log of x plus 1 over root x minus 2. Okay, everything is. But what I can do with this function, I can use the logarithmic property and rewrite the function before taking the derivative. When we dividing a number, this actually means that before we did have subtraction of these functions, because the other way, when we subtracting the same logarithm, we can divide these inputs, these arguments. Also, this is simplest form, but square root means that I am taking my quantity to the power of half. And also one of the property, that 1/2 I can place in front. That means my function is natural log of x plus 1 minus 1/2 natural log of x minus 2. Now, really easy and simple for the simple form for the derivative. Okay, derivative of ln of x plus 1 is just 1 over x plus 1, and derivative of x plus 1 is 1. Minus, copy a constant, 1/2 is a constant. Derivative of ln of x minus 2 is just 1 over x minus 2. Derivative of this is 1. And I can leave it, but let's maybe do a little bit of algebra, and let's find a common denominator, because we have 2x minus 2. It means the common denominator is a product of both of them, and this means that I have to multiply the first fraction by 2x minus 2, 2x minus 2, and the second fraction by x plus 1. And just the algebra. And let's see what we have. We will have 2x minus 4, okay, and then minus x minus 1, because this negative will affect that x and will affect that 1. That's the reason that I have negative 1. And then I can put the entire denominator, 2 times x plus 1 times x minus 2. And what's happened on the top? 2x minus x is x, and negative 4 and negative 1 is negative 5. Okay? Nice, rational, proper rational function. This is the final answer. Okay, and what else? Oh, another logarithmic and compound function, actually, the composition of lots of functions. Again, my note is no product rule, because we have logs, logarithmic function of cosine square and cosine square of ln of x. As you may notice, natural log of x is an angle of the trigonometric function. Okay, if the base is not written, we remember is 10. Let's start. Derivative of log base 10, it's 1 over the entire quantity. Cosine square of natural log of x, and since the base is 10, I have to multiply by ln of 10, and times derivative of cosine square of the natural log of x. Okay. Cosine square of the natural log of x and natural log of 10. Now, derivative of cosine square. Derivative of cosine square of the quantity square, like let's say x squared. Derivative of x squared is 2x, 2 times the quantity. That means derivative of cosine square is 2 times that quantity, that cosine of ln of x. Follow the chain rule, 2 times cosine times derivative of cosine. Derivative of cosine is negative sine, which I can put sine, negative sine of the same angle. Negative I can put here, okay, because everything is product. Let me put here. That negative is from here. Okay? But one more time, I can maybe write this. Derivative of cosine of x, cosine square of x, just for you to have. It will be 2 times cosine times derivative of cosine of x, which is negative sine of x. I mean, this is the derivative. But we do have another, the most inner function, which is an angle, natural log. And we still have to follow the chain rule. Derivative of ln of x, it's 1 over x. That means one more time. Cosine square of ln of x is 2 times cosine of ln of x times derivative of cosine, which is negative sine of the same angle, ln of x, times derivative of that angle. Okay. And I think I can put negative 2 sine of ln of x times cosine of ln of x and times 1 over x, which actually I can drop that x in the denominator, and then cosine square of ln of x times ln of 10. Okay, the only thing that I can simplify, I have one cosine and another cosine. I can cancel them out. And I will drop that x down to the denominator. And I will have negative 2 sine of the natural log of x. And I will put x and ln of, or maybe I can write still cosine of ln of x, and then ln of 10 and that x, yeah, that 1 over x. I just realized that I have sine and cosine of the same angle, the ratio, which I can say is tangent. And we will have negative 2 tangent of ln of x, and the denominator will be just x, natural log of 10. This looks like a most compact final answer. I don't like this negative. Let's write like that. Okay, I think I have 1 or 2 more. Stay with me. Okay, differentiate y equals to 2x times log of square root of x. Probably I can, oh no, let's simplify. Because this is log of x to the power of 1/2, which I can actually say this 1/2 can be placed in front. And actually 2 times half is 1. I did simplify to the function x log x. Okay, product rule. Derivative of x is 1 times the second function plus x times derivative of the common log of x. It's 1 over x times natural log of the base, which is 10. Okay, and I think we can rewrite log x plus x. Oh, actually, x and x I can cancel out. Really nice. ln of 10. Okay, I believe this is the final form. Okay, and the last one. Differentiate cosine of natural log of x over 3. No product, just two inner function. Okay, derivative of cosine is negative sine of the same angle. See, I copy this, times derivative of that angle. Derivative of natural log of x over 3, it's 1 over x over 3. And times derivative of that x over 3, which is just 1/3. Because x over 3 is like 1/3 x. And derivative of this is just that constant, 1/3 slope. Okay, we do have a chain rule twice. That means let's just rewrite nicely. I can put maybe that 1/3 in front. Oh no, let me simplify a fraction. That means I will rewrite this. Okay, I can flip this fraction. This will be 3 over x times 1/3 r, and actually I can cancel out. Okay, that means the final answer is just negative sine of natural log of x over 3 all over x. Also a really nice answer. Okay, I think the 12 problems gave you a variety of different types of the function, including, of course, logarithmic and exponential. Please practice them again. Please solve them again. Okay, thank you very much.